Dear participants, thank you for joining and welcome to the virtual Fireside Chat Series. The topic for today is AI solutions on the speed of light, role of computational resources. We have Professor Ajith Abraham, Vice Chancellor and Dean School of AI, Sai University, and we have the speaker for today, Dr. Leszek Sliwko, CEO Meta Analyzer from UK. Very warm welcome, sir. And Professor Ajith, sir, over to you.
Thank you, Nilay, for that quick introduction. I think we are already like 3 minutes late, so let me get into our program right away. It is indeed my great pleasure to welcome Dr. Leszek Sliwko, who's the CEO and founder of Meta Analyzer based in the UK. So we know each other since I think over 5 years now. I think we did a seminar together during the COVID times. We did, I think, the labs which I was working for those days. We did 24 seminars in like 3 weeks, connecting the world. And I think we kept the scientific community busy during those bad days. And it's my great pleasure to welcome Dr. Leszek back to stage one more time. And seems like he has become more younger now. so, so he received his PhD degree in 2019 in the field of distributed computing, particularly, I think his thesis was dealing about AI-driven load balancer for cloud-based systems. And he has been working in the industry since long time. So he has been working on several, I would say, real-world projects, specifically from the UK government, the telecom industry, fintech. From an academic perspective, he has several publications and journals, conferences. If you look at academic databases, you can find his contributions there. So what we'll do today is, I will, like probably we both of us will give a quick, like a position about what is going on in this field. Like AI is progressing at one scale and a dependency on high performance computing, and what are some of the challenges. So that is a main topic for today. And towards the end, we will also have a platform for interaction with the speakers. So I guess I don't have to introduce more about AI. AI is like transforming the way we live, the way we do many things, from drones to self-driven cars to robotic surgeries. So nowadays you hear the word smart cities, smart hospitals. I guess when I was a kid, I used to hear only about smart kids, but nowadays everything's kids are gone. Now it is more towards objects and systems. So the world is evolving in such a direction. Specifically, the invention of transformers, large language models during the last uh, 7, 8 years, we have seen the the field of generative AI booming into a very different direction. Specifically, its contribution in generating contents, whether it is text, whether it is images or media, even videos, to even multimodal things. So we are scaling up applications to various dimensions, and we are seeing the impact in several professional domains. Specifically, I would say in the media industry, in healthcare, in legal industry, agriculture industry. I would say in even in like government organizations, you will see the impact of generative AI, in a very big way. So that is generative AI, and I would say a little bit deeper into some of the specific learning mechanisms. For example, reinforcement learning has also been doing wonders in the last few years, and basically a lot of applications for optimizing various strategies, specifically in supply chain and various business operations, and specifically because of the improvement of explainable AI. That is sort of because many a times AI is more like a black box. So And recently, I would say the last 3 4 years, a lot of specific improvements in the field of explainable AI is improving a lot of contributions in the field of healthcare and fintech, finance industry. And specifically in AI healthcare, I think we are seeing numerous inventions. Uh, I've been reading in a lot of news about generative AI, even performing better than like traditional uh, diagnostics. And we have seen a lot of, I would say, articles and real case studies where AI has proven to be very useful uh, to to give insights to medical doctors. Uh, Apart from like robots being assisted for surgeries even remotely, and you might have heard about nanotech, nanorobots going into the body and doing massive things, which I think was only under imagination probably several years before. So tech is progressing, in a very big way. In biometrics, specifically, you might have seen face and fingerprints everywhere now. So many countries and even some zones, for example, in Europe, in the US, Australia, New Zealand, many Singapore, many countries, and you can just walk in even without a passport. You just need to show your face, and then you're already inside. And similarly, like payments, border control, authentication, has all become so easily because I think AI has proven to be a very robust and useful technology. And even with the help of federated learning, which helps to train uh, I would say a particular like a problem on various decentralized devices, which also enhances privacy. So basically it also you can actually build AI health AI based healthcare applications. So that also preserves privacy at a very large scale. And I would say specifically last few years, natural language processing, has had made a lot of impacts, and you can see how these days chatbots are performing compared to 6 7 years ago. When you visit a bank or when you visit some industry or university, you will see some very simple basic chatbots, and nowadays you will see very interactive, and you always feel like you almost feel like some human is behind that, and I would say in real time, and can imagine real time translation as well. So nowadays, I think we don't feel that we need to study a language to go to a country. With all these online quick translators, you can actually get all the information in hand. Besides that, AI is doing, I would say, large scale miracles, specifically in solving some of the Sustainable Development Goals set by the United Nations. There are 17 goals starting from poverty, healthcare, education, uh, gender equality, various other, yeah, things. And I would say AI is able to, like assist, I would say, many of us to solve, understand some of these complicated problems. For example, understanding global warming, like, and providing sustainable environmental solutions. Similarly, I think education and research. I think it has gone a long way. I think specifically in research, AI or I would say generative AI has been like very much used for augmenting data. So and for speeding up simulations, it would have taken months or years to simulate because specifically in certain industries or domains like healthcare or in finance, bad things happen very rarely compared to good things. So getting those data is very difficult. So augmenting data, AI has played a very big role. So I would say that is, the positive aspect of AI. But the negative aspect is, like AI is heavily dependent on computational resources, specifically the large language models. And even when you have complex data of I would say what we call as big data in academic community. So when you have big data, we also need to handle all these massive computational tasks, whether it is data cleaning, data pre-processing. We are dealing with terapetabytes of data, and you can imagine storage of the data, then networking, reading this data, and then handling all this data using some I would say AI methodologies. So and you can imagine the the massive task. And model training, of course, is one of the I would say the most uh, heaviest computational tasks. And typically thousands or hundreds of thousands of GPUs are connected in parallel, typically I would say in university environments, because typically universities cannot afford to go for such massive processing power. And you can imagine specifically all these media generators nowadays. You have all these crazy media generating tools which anyone can generate via medias. For example, you upload a photo and you're getting a cartoon, or you're getting a video out of yourself. And imagine like hundreds of thousands of people using these platforms, and you're creating a huge load on these systems. So for those who are new to all this, NVIDIA is one of the forerunners, and they have this HPC clusters, NVIDIA 100, H100, H100, and even this Google has tensor-based processing units like the TPU V2, V3, V4, and many others. Similarly, I would say there are custom-based supercomputers, like having a mixture of all these things. So still, I would say, it is a long way to go. So fine tuning and adapting, all these things, I would say is a massive uh, challenge, because you build a model just like any AI machine learning model, and you build a LLM, and then you find some results, and then you need to fine tune those parameters. That is more like like retraining or adapting to your latest data. So that itself is another additional load. So you can imagine the the processing needs. And finally, generating responses in real time. So for example, like all these GPT platforms, or Llama, Gemini, or DeepSeek, all these platforms, you're put you're giving a prompt and getting the answer in I would say a few seconds. So real time responses, specifically I would say images, videos, multimodal things in real time. You can imagine the complexity involved when we use these platforms. So you're seeing both sides. One is technology is at the same time the way we are doing things. We also need to provide a lot of computational resources. Fortunately, I would say like 10 years ago and now, I would say the cost of GPUs have gone down. For example, like even someone can afford a 3,000 core GPU for a reasonable cost, like 400, $500 nowadays, which was thousands of dollars 10 years ago. So the cost has gone down tremendously, but at the same time, the volume of data, and the availability of different technologies have also grown up. There's a huge challenge to find this balance. So I think this fireside chat series will open up some discussions to find out what is going on. And I'm sure that all of you will get some benefit out of this. And once again, I would like to welcome all our attendees from different parts of the country, world, to this fireside series. So with that, I will close my opening remarks, and I will pass the floor to Dr. Leszek Sliwko.
Thank you very much. That was a very good introduction, especially where we are in the state now. Like Professor said, costs are going down, but also the appetite for the models. I will try to demonstrate a bit of that, how much computing resources we need to even train a simple model. I think the introduction was done. I think I can jump straight away to my presentation. Please let me know if you see my presentation. Should be coming up now.
Not yet, not yet. I think you haven't shared yet.
Okay, let me test to share. Sorry for that. Is it coming up now?
Perfect, perfect. Yes, please go ahead.
Perfect. All right. So first thing first. AI and machine learning terms encapsulating the whole range of algorithms, starting from algorithms like a decision tree, scheming, clustering, and also part of the algorithms was deep learning or artificial neural networks. And the last one will be focusing on while those first one baseline models like I mentioned, decision trees are good. They are more specialized. They are not really great for every problem, and especially not a complex problems like a natural language processing. The whole design of the artificial neural network started in 1950s when United States Navy research project. They designed a machine called perceptron, which was basically nothing else than a single layer neural network. Of course, the capacity of then computers were not good enough. Therefore, project was went nowhere. Therefore, what you see now has been started 8 years ago. Only now we have enough of the hardware capable enough of running those models and scale them to the size which makes sensible to run them. Let me start running to the code directly. Please don't be scared. Right. I'm a big fan of PyTorch, which is the programming language. Sorry, it's a programming framework which is used to construct and run models. PyTorch is written in Python. However, if you start digging into the classes, you see that lots of that is just C++, Objective-C, other bindings. Therefore, Python is just the tiny wrapper on top of all the computation. Some of those libraries in Python are very old. Sometimes 30 years old. Some of those algebra libraries written in Fortran, Fortran 7. Therefore, this framework down there is very old. However, what I want to show it here, this is a very simple classifier model. It has 2 layers. It has 100 input neurons in the first layer. Has 20 neurons in the hidden layer, and classifies the input like a yes/no. So this is a classes count. This is what has been highlighted. Therefore, 100 input. 20 hidden neurons, and output is yes or no. Simple binary thing, classes. Definition of the model is in PyTorch is reasonably simple. We just define the sequential order of the layers. We also define the rectifier linear unit activation function, which is pretty standard for any linear layer. What's important into that? As Professor mentioned, aside from the developing mathematical model, also the hardware evolved a lot. Nowadays the CPU is good enough, it's fast enough. However, it's not fast enough to make this computation in real time. Therefore, hardware providers, vendors, design a specification how we can tap into this additional power. It was the master stroke on the part of NVIDIA, who, aside from the building graphic cards which you can play games at, also provided CUDA interface and pushed very hard to make sure that there's a good support for CUDA in all the drivers. Originally, CUDA was just a way to access the computing power of the GPU, which then were primarily used for render graphics games. and I don't think they were expecting the CUDA to be ever used for the deep learning. However, it was. Therefore, you can see on the last line, I'm also loading up the memory, the create model and memory into the device. Depending on which hardware you have, sometimes we have to just run on the normal CPU. For any NVIDIA card, usually CUDA is available. Therefore, we define device into run. Another element we need to notice is the precision. By default, we're using float32, which is full precision, which takes 4 bytes per parameter. However, the specialized hardware, like which I will mention later, NVIDIA A100 RTX series, can use half precision with 16 bits. Why I'm mentioning that will come obvious later. All right. Therefore, this is very simplified. This is a very simple model. Like I mentioned, we have 100 input parameters, 20 hidden neural networks, and we're just answering yes or no. This is the output of the classes. How much memory it takes? We need to dig a little bit into the how it's constructed. We have 2 layers. First layer has 100 inputs. This is weights and 20 outputs. That gives about 2,000 parameter. However, linear model also have biases. This is additional value added to the neural network activation function, which is each one for each output neuron, therefore 20. Therefore, for the first layer, we have 2020 tremble parameters. For the second layer, which is much smaller, we have 20 inputs and the outputs only yes or no, therefore 2 classes. Therefore, we have 40 tunable parameters plus 2 biases, because for the two output neurons, that's plus 2. Totally, we have 42 tunable parameters. Totally, that gives us about 2062 tunable parameters. Now, I mentioned we're using float for each attributes. Therefore, we multiply 2062 times 4 bytes. That gives about 8 kilobytes of memory used for storing model. So this is how much model we take in memory, which you keep. It's not much. If you ever work with PyTorch, the easiest way to calculate the number of parameters is to use the state dictionary, which you can call by .state dictionary. Inside this dictionary, there will be items like FC1 weight, FC1 bias, FC2 weight, FC2 bias, and this is for the linear network. So for linear layer, for other layer might be of course differently. And this is the easiest way to find out how many parameters actually stored. Those parameters will be stored in tensors. Tensor is the object structure used in PyTorch. It's basically a multidimensional array. So this tensor is actually loaded into memory. Hopefully, if you have a hardware supporting the CUDA interface, hopefully that will be in memory. Okay. Now let's multiply it a bit. So we know that our model takes about 8 kilobytes memory. That's not much. Let's be honest about this. However, training that's completely another issue. For training, depending which optimizer and which algorithm you use, we always need to have some activation memory. For that, we need to have a double for the forward and backward parsers. This is the place when the gradients are stored after each batch. In this case, batch size. By batch size, I mean how many samples are we feeding into our model during training in one go. At the end of the presentation, I will give a couple of links to the Google Research Base tuning guide. The advice is to use as big batch as possible. In my own research, I'm using batches around 64,000 and higher. Because I have a pretty good graphic card. However, in here, for example, we're just using small batch. It's just 32 data points. To store that, we need about for input tensor, we need about 12 kilobytes of data. For hidden layer, we need about 2.5 kilobytes of data. We need to store also output, which is very, very small. And please also remember that we need to store it for the forward and backward parsers, which gives us around 50 kilobytes of data. So this is for every optimizer function use. This is the storage. Depending on the optimizer use, here the most popular one is Adam, which is working pretty well. It keeps two states. It keeps two moment estimate and keep the variant. Typically, a optimizer works in 32 or the 32 bit floats will be imported later. The total memory usage for training this model with 32 byte size is about 54 kilobyte memory. If we increase the byte size to here, example here for 512, we need about half a megabyte memory. It's not much. Just please remember that this model is only about 2062 parameters. Now let's go for the big boys. ChatGPT-4, we don't know how many tunable parameters is. The best estimation provided is about 1.8 trillion tunable parameters. I will mention that a bit later. However, we have a pretty good statistics for GPT-3. And GPT-3 is 175 billion parameters. Assuming that we can store those parameters in float 16 instead of float 32, that's 2 bytes per parameter, we have about 700 gigabyte of memory. As you see, this escalated quite quickly. For training memory, of course, we need to maintain our 700 gigabyte model memory and also add the optimizer states, so double that, 2 states per parameter, that's about 1.4 terabyte memory. And we also need to keep a bit of activation memory. Here we can use optimizations, but that's again like a 350, maybe 500 gigabyte per training steps. In totally, we need 2.5 terabyte of data in the fast access memory. Like I mentioned, GPT-4, we don't have a stats yet. The best estimation I saw is about 1.76 trillion parameters, which is massive. However, in terms of GPT-4, the most likely architecture is using 8 separate models, which is called a mixture of experts. Each of those models have a 220 billion tunable parameters each. Therefore, they will be comparable. So we can estimate that to train up the GPT-4, we need about 8,000 times 5 terabyte memory, about 20 terabyte of memory. However, we don't need to train all those models at the same time. Like I mentioned, the most likely architecture is 8 models. Therefore, we need about 3 terabyte each to train each of these models using GPT-4. Please write those down, those values, because we need to use them a bit later. I'll show you how much hardware costs to train the top. Just to compare, human brain, the closest, I think, comparison would be not the neurons, but synapses. The difference in neural network model and the human brain is that each synapse doesn't connect to each other, to every other neuron. It connects about 10,000 synapses, or only about 10,000 synapses, not to each of them. Therefore, the number of weights will be much smaller, which are about 1 quadrillion still, tunable parameters. If you want to model the human brain, that would take about 2 petabyte of data. However, it runs on the 20 watt. Therefore, don't be afraid. AI is not replacing us now. The human nature is a way better designer still. I'll be presenting the number of energy used for models. We are happy. We still run on this small battery. All right. Therefore, I think you know how much memory we need. Why memory is important? To train GPT-3, Microsoft built a supercomputer for OpenAI. The supercomputer, this is pretty well published. I provided some references to that one. It uses about 10,000 GPUs, likely NVIDIA V100, which is a bit older model. I have some photos later down the line. And uses also lots of CPU. Nowadays, hardware is, of course, much better. I don't think that many CPU cores needs to be used. Nevertheless, still. What's important? Because to train GPT-3, we needed about 2.5 terabyte of data. And current GPU devices can provide us 40 to 80 gigabyte of memory. Therefore, there was another methodology used, which is called a model parallelization or data parallelization. Model parallelization Model parallelization technique uses a number of interconnected GPUs or CPUs, if you don't have free GPUs, and exchange data between them. Data parallelization uses a number of physical boxes which are connected by a network. Obviously, the faster training will be on the same physical box. Therefore, model parallelization is way faster. However, we don't have a hardware yet who can store 700 gigabyte of the fast access memory, or maybe 2.5 terabyte of memory to train the model. Therefore, training of GPT-3 had to be distributed. A training cost of GPT-3 and its lower estimation is between 4 to 5 million USD, quite a lot. The higher estimations are around 70 million, just not disclosed. The sources of the data are internet, 60% of that, specially crafted web test of curated web pages prepared previously by OpenAI. Also public books, Wikipedia, but the special subset of Wikipedia called Wikipedia dump, and other sources like GitHub, academic papers, news. As you can see, the academic papers are not that much actually when ChatGPT-3 was trained. I provide a couple of more references down on this slide. Feel free to check. Let's move on. For the hardware, like Professor mentioned, there are currently two main hardware vendors. One is NVIDIA and one is Google. Google provided TPUs, tensor processing units, which are available only in the data centers, or that some clients have on-premises installation as well. There's not much information. It's not that much information about tensor processing units as about GPUs. Probably the most interesting one is the cost of processing, which is about $1.2 cheaper per hour. There's a number of versions. TPU V5E seems to be the most cost efficient one. From another side, NVIDIA provides a GPU, and which are quite well documented. Many publications can read about online. There's a lot of information online. Like I mentioned, NVIDIA did a masterstroke, and early in development pushed for clear specification and support for CUDA, which was designed so the primarily game producers could tap into the additional power of the GPU processing. The support for both TPU and GPU are well spread. Probably the most common framework is PyTorch. However, lots of companies also using TensorFlow. TensorFlow is obviously only for the Google, but you can also load up plugins which allow you to connect to CUDA. I personally mostly work with PyTorch. In terms of the hardware, if you have $8,000, you can buy yourself 40 gigabyte of A10, and the prices go up after that. $20,000 for the 80 gigabyte version of the A10, and newer model H100, which costs about $33,000. Of course, you can always run them. Probably the cheapest place to run them out is currently the Amazon Web Services. I don't remember the exact prices from top of my head. Like I mentioned, here we'll be focusing mostly on NVIDIA. I provide a couple of images. So the first one is very rare nowadays, is V10 Tesla. This is what on GPU, so ChatGPT, so GPT-3 model was trained. The probably most used in the data centers now is the A100 series. This is 40 or 80 gigabyte versions. They provide between 4 to 8 GPU cores. And they've been discontinued in January 2024. And they are being replaced by newer version H100, which you can place orders starting from this January this year. When we're talking about hardware, we cannot skip energy use. And this, like a professor mentioned, is probably the biggest headache. To train GPT-3, we used about 1.3 thousand megawatt hours of energy, which is equivalent of about 380 Indian households' annual energy usage. In UK, the energy usage is about 50% lower, about 1/3 lower, which is 2.2 kilowatt hours per year. It's quite a lot. The second most energy consuming model I could find was transformer to transformer. This is part of the neural architecture search developed by Google, which is roughly half of the energy used for GPT-3, which is about 656 megawatt hours used. To compare the typical BERT, this is BERT base, is only about 1.5 kilowatt hours. It's a lot of energy. At the moment, data centers are set up in the country which has a low energy cost, which is why United States of America built so many data centers. Energy cost in UK is about 4 times more than I'm talking about the commercial energy. It's about 4 times more than US. I don't think data centers with AI capable hardware anytime soon. It's a huge cost. Let's go back to you. Let's go back to the overview and now focus. Who is the main user? To be honest, practically everyone. Embedded services, search engine, social media, or e-commerce, it's about 4 billion users. Conventional GPT, so people who directly use places like a ChatGPT, Siri, Alexa, it's 1.5 billion users. AI in applications like Netflix, YouTube, TikTok, are the 7 billion users. Please note this is not unique users. Same user can use a couple of different social networks. For the generative AI, and here's a bit of a complicated term because generative AI is also used for the conversational AI, therefore like a ChatGPT. However, directly for generative AI, like images, like a Midjourney, DALL-E, estimation is about 200 to 300 million users. In terms of the professional use of AI, there's no statistics, but pretty much 80% of the Fortune 500 companies are using AI in some stage. In my place of work, there's a new ChatGPT-like service because we are very heavy in Azure as well. By the way, the ChatGPT-3 was trained on Azure, and currently Microsoft exclusively licensed ChatGPT just for their own. Of course, you can use the API to communicate with it, but in terms of access to model, only Microsoft. In conclusion, half of the planet uses some kind of AI. It's not a silent revolution anymore. In terms of market value estimates, of course, there's Bloomberg. Bloomberg always overestimates those. The spending on the AI exclusive research development will be growing. Bloomberg says at least 2 to 3 times. The spending currently is about 200 something billions, but that will be in about 1.4 billion in 2030. That's estimation. Therefore, is the area worth observing. We're coming to the end of this short presentation. The topic of AI and machine learning are vast. I mentioned some of them. However, if you want to really research the subject, obviously you need to learn about different optimizers, loss functions, different way of training that, especially overfitting, underfitting, biases. If you're training really huge models like GPT-3, you need to also learn about model parallelism and data parallelism. In terms of this will be another question asked later. However, we don't need to train every model from the scratch. You can use existing one, and this methodology is called transfer learning, which also has a couple of different features like feature extraction and fine tuning. I can speak about it a little bit later if there's an interest of that. Once the model is trained, we of course need to have some way of evaluation. Typical accuracy is how many responses are correct. Is obvious one, but we can dig more into that. Start looking into precision, recall for given class, FC1 score, also called harmonic score. And if you really want to see the outputs in details, there's a construct called confusion matrix. In terms of PyTorch, there's not good support for evaluation. However, you can use the functions from the scikit-learn, which is probably the easiest way. That's how I do it, at least. Of course, when you're talking about deep learning, there's different type of the network architectures, collusional, long, short-term memory storage, transformers used for natural language processing mostly, and hyperparameters. Of course, we need to touch it as well. In this presentation, I don't mention that because there's a lot of that. So thank you very much for your attention. I think it's time for questions now.
Yes. Thank you so much, Dr. Leszek, for that wonderful overview. You have covered the entire space in a short and deeper.
Very short.
I would say in breadth as well as in width. So I think within the nominated time. So thank you so much. So now we have time for some questions. So audience, if you have any questions, you can raise hand. You'll see, I think, a button on the bottom, and then Mohan Vamsi. Okay. A minute, I'm just trying to figure out. Yes.
Good evening, Dr. Ajith. Good evening.
Hi. Yes. Please go ahead.
Yeah. So my question is that I've lately observed observation that I've seen a growing discussion at a lot of discussion forums of different competitions, which had a main point that there's a growing division between the resource rich and resource poorer groups. Now, as we are the future torch bearers of the technology, what can we do to lessen this gap? Not just to promote equal opportunity, but also not losing out the least compute intensive solution that may come from a resource poorer group.
Okay. I think at the moment, the models are growing. They're exploding effectively. And they will be exploding because there's a need for more and more detailed models. I saw that applications like Gemini, ChatGPT are introducing different tiers of models. Of course, the more advanced ones are paid. By default, they're using the smallest model available, something like a daily usage. However, they also offer the option to switch to more advanced model with bigger knowledge. I think that because of the cost of using big models for everything, it prohibits such waste of resources. I think the companies will offer small model by default if the answers given are not good enough. Then you have an option to use the more provide more expensive models as well. Does it answer your question?
Yes, kind of. Yes, it does.
Thank you.
And I think I think from the user's perspective also, I think I was reading some post from OpenAI. They were telling that that to minimize your prompt text contents, even good morning or thank you can reduce the working load on the machines. So I think users also needs to be educated in some perspective. And I think from an academic perspective, I guess we should always look for like efficiency and scalability, than looking for bigger models. And I've seen many a times nowadays researchers, they, like they don't talk about, how much how the computers, the computational resources they have used, the computational load, these things are kept aside because they believe that it is no more important. But I think in the community, I think, like I remember, like 10, I would say 20 years ago, these things were mandatory. Whenever we publish a research publication, these things were mandatory. But nowadays, people don't share these resources. I think community needs to be more transparent, and I think so that we'll be aware of what is going on when you do such experiments in terms of energy requirement, efficiency, scalability, and also how we can select specific hardware related to like the problem. For example, if it is like a deep learning or heavy machine learning tensor based computation, you need such such computational resources than using like traditional GPUs. So I think we should understand the hardware, uh, specific hardware which are useful certain in specific tasks as well. So I think the community also needs to be educated at large.
Actually, this can be expanded further. There's also a question of precision. On this first slide, which I presented, we're using float 32, which is 4 bytes. ChatGPT-3 probably was trained on the float 16, so this is 2 bytes. So you see, we have twice amount of memory. How about decreasing that even further? It means using maybe even int, that would be 1 byte, or even maybe half a byte, would be 4 bits. Potentially could fit a bigger model, but then it's a trade-off of precision. So that's potentially another direction. I think that right now the models, functions, optimizers, loss functions are pretty well developed. I think now there's a switch towards how we can optimize the process. I started seeing some publications about pruning. For example, when we're removing unnecessary neurons or the whole layers even, maybe that's the way.
Yes. Thank you. Like for applications like self-driving cars, robotics, or like fintech applications, in such cases, a decision should happen in few, I would say, milliseconds. So, and imagine using these platforms, and if you want to guarantee real-time performance with limited compute resources, it's a huge challenge. What are your views, like from industry perspective, how we can manage such cases?
The cars and data centers are a bit different. The cars, we have to work with the hardware we have on board. In terms of fintech, you usually have some data center, or maybe in premises if the fintech needs that, which can be shared. In terms of cars, usually the computer cannot be shared between different cars. Therefore, it's much more limited because the car costs amount of dollars, and if we start building in very powerful computers, this price will be too high. therefore, I think this is two different things. In terms of the fintech, if there's no some crazy requirements like computation has to be done in nanomilliseconds, I think sharing data center is perfectly fine. Therefore, a couple of companies can pool resources or maybe use something like a cloud provider like AWS that will lower the cost. And of course, because the resources are pooled, the vendor can also upgrade those machines all the time. So newer, better hardware, we can upgrade it. In terms of the cars, this is more complex. We won't be exchanging computers on the cars if there's newer model, and because onboard computer has capacity, those models must be much more efficient. I don't know much about cars, to be honest, but potentially we can use some more specific, more I don't know, real-time friendly models like a efficient net, maybe some YOLO Nano models, maybe mobile net. There's also I was also reading something about tiny transformers for sequence modeling. Maybe that's the way for the cars, but I'll separate the cars from the fintech, which can use some data centers.
Thank you. Thank you. There is a question from Anne Rishendra. She's asking, can I know the various aspects involving in the security which are used while training an AI model?
In terms of the system security, I think this is pretty much like everywhere else, just need to provide DevOps. In terms of the data that model is learning, oh, well, yes, that's a very good point. There's not an easy way to examine what model learn. I mean, there's no way to debug it. The typical neural network start examining is just data, lots of numbers. There's just no way to examine that. It's a black box. I think the filtering needs to be done on the data we fed into that model. We need to shoot it effectively. Early instances of the open AI models, some users were able to manipulate it and provide either a racist comment or things like that. There's a need for filtering input data. Once the data is in the model, I don't think there's a realistic way to examine that.
Thank you. Any other questions? If any of you have any questions, please post us in the chat box, or if you can raise hand, then we'll allow you to ask the questions directly. Probably we can take 1 or 2 more questions. We have 5 more minutes to go. I see Professor Abdul Karim. Abdul Karim, are you there? Looks like no more questions, huh? So let me ask something to keep us busy.
Perfectly fine.
So like coming back to training these models. So if you split the training across multiple devices, like GPUs or clusters, whatever it is, adds additional communication overhead, and finally synchronizing these model updates efficiently across all these GPU clusters without spending more time is an additional challenge or brings an additional burden. So how do you think, what is your viewpoint about this? How we should go about it, from a practical side?
With the focus on communication overhead. That's an interesting question, actually. So we have so generally there are more or less two ways of training a model in distributed manner. First, we do model parallelization, which we are splitting model across devices, so GPUs. If you have this 800 NVIDIA 800 GPU, there's 8 cores. So model parallelization will be just splitting the model. It could be, for example, first layer on the GPU 0, layer 2 on GPU 1, things like that, and they communicate with each other. If you can fit model in that device, that's fine. The communication between GPU is very high. The latency is terabytes per second. It's not a problem. Like I said, the question is if we can fit the model in such device. I think the more interesting will be the data parallelization, when the model is so large that we cannot fit it in the one physical device. We have to use interconnected boxes. Then the highest cost will be to aggregate gradients. So after each steps, we're running different batches on different physical boxes. Each of those, after running each step, we have different gradients on these models and needs to be aggregated. So that will be the cost. If let's say we have a model with 100 million parameters, that will be, let's say, using float 32. Like before I mentioned, let's use Adam. Let's use Adam optimizer. That will be about 400 megabyte of gradients to be exchanged. It's not that much. If you have a good network connection, like Azure works on the Infinity broadband, that should be fairly straightforward. Yeah, I don't think with that much of the issue communication, as long as we have a powerful network.
All right. Thank you. I think we can take one more last question. There's a question from Anne Rishendra. Can you talk? Hello? Can you hear us?
And you have the permission to talk. So if you can ask your questions yourself. And also, sir, meanwhile, we have one more question from the anonymous user. So we have a question from an anonymous attendee. So as a beginner in AI/ML model, which computational tool should I start learning first?
Well, I think it's a very, very foundational question. So I think you should learn some I would say basic models. For example, like decision trees or a simple multi-layered perceptron, some clustering algorithms like k-means, very foundational models. So, and then you try to understand how these base models work, and then you try to improve further. There are several libraries available, and you can try it out and then further develop. So AI is a big field. So for example, there is a B.Tech program in AI which typically has more than 25 different courses covering various aspects of AI. So you can imagine a 4-year program, and like AI is all about, like I said, foundational models. Then certain models are based on data-driven data. So you could apply them in various applications, projects. So all these, could be, like it is a I would say learning experience, which I think we cannot really summarize it, in 5 minutes. So it is like a journey. AI is more like a journey. Like myself, I've been learning this, I would say, the last 30 plus years, and still I feel I'm nowhere. So the field is progressing so fast. So you can always start like the way I mentioned, like some foundational models. If you go to, like YouTube, you can find some very basic lectures about AI, and then you can also try some libraries. I'm not really sure what's your background. If you are in Chennai, you can visit our university at some point, and you can see our programs. So we have a B.Tech program in AI that's launching this year. And apparently, Dr. Leszek is also an industrial advisory board member of the School of AI. So I hope that we will get the chance to have many more webinars, fireside chats, as well as probably some uh, real meetings as well in the future. So, any more questions from the audience? I guess we are running short of time. There's a question from Sheikh Rushma. Do you think this leads a big profit or loss for upcoming students in pursuing jobs? Well, I don't see that AI is going to replace humans, human or human assisted things in a big way. But I think we should usually utilize AI, to the best possible extent. So I would say we should use AI to augment the things which you're doing. So I think if we sleep, then AI will take over our jobs. So there is a need for us to enhance, upgrade our skills. For example, if someone is doing clerical jobs, probably I would suggest he or she should, study or should be able to use basic Gen AI tools, for example, generating text, media, enhance his or her productivity so that, uh, uh, like she or she may be able to do, like three, four, like jobs, which three others together, would be able to do. So AI helps us to scale up our own productivity. At the same time, it helps to improve the efficiency, quality, etc. So always, we should see AI from a positive perspective than, seeing that AI is going to take over our jobs, etc. Especially for youngsters, I think, all of you needs to, like roll up your sleeves, work hard, and, like try out. The world is yours. Now anyone can do anything, even from your room. No need to be in a university, no need to be, in a lab. All you need is ideas. That's it. Just need ideas. Like how Uber, Alibaba, Airbnb, all these companies, the way they have started up and how they have scaled up, it is unimaginable. So I think all we need is ideas. So I think with that, let us, close our second fireside chat. I would like to thank all the attendees for being with us on a Sunday afternoon and wishing you a nice day ahead. And I would like to thank Dr. Leszek Sliwko for the wonderful time, the inputs uh, from you, and I looking forward to interacting with you in the future as well. Thank you so much, and let's be in touch. Have a good time. Thank you all. Bye.
Yeah, from my side, thank you too.